Hi, in this video, I'd like to look at trigonometric ratios and how they apply to right angled triangles. Let's start by drawing a right angled triangle, and we can name the triangle A, B, and C. Now, within the triangle, we draw curves just inside each vertex to show that there is an angle. Inside the curve, we can name the angle. If we know the size, we can write this value inside the curve. So let's say that this angle is 30 degrees. If we don't know the size of the angle, we can give it a name using a Greek letter. So let's call this angle theta. If there is a square inside the vertex of the triangle, such as this red square over here, it shows us the angle is 90 degrees. A right angled triangle will always have one 90-degree angle. It does not matter where the angle is in the triangle. As long as the angle is shown by a square, it is a 90-degree angle. Another name for a 90-degree angle is a right angle. The hypotenuse is always the side directly opposite from the 90-degree angle. So on our triangle, we can write hypotenuse over here. No matter where the 90-degree angle is in the triangle, the hypotenuse is always the side directly across from it. In geometry, we learned that we can name the side of a triangle by the vertex directly opposite it. A vertex is the corner of a triangle, and in this triangle, we've named our vertices A, B, and C using capital letters. So to name our sides, we can use these letters, but in lowercase. We can draw a line from A to the opposite side of the triangle and name it A, but in lowercase. Now let's look at the vertex C. We can draw a line to the opposite side, and we can call this side lowercase c. If you're not sure how to name triangles, please go and watch our videos on this in the geometry section. In geometry, we have learned about the Pythagoras theorem. This theorem states that the length of the hypotenuse is equal to the square root of the sum of the squared values of the other two sides. So we can write this as h, the hypotenuse, is equal to one side of the triangle, let's call it A squared, plus the length of the other side of the triangle, let's call it C squared, all under a square root. Now, if we have the length of the hypotenuse, we can also rearrange this equation and make one of the other sides of the triangle the subject in this equation. So let's say we're trying to find A. So we can say A is equal to the value of the hypotenuse squared minus the value of the other side squared, all under a square root. Let's make some space and write our notes up here. Now we can look at an example. Let's say that side A is 3 units and the length of side C is 4. What is the length of the hypotenuse? We need to solve for h. So we're going to use this equation where h is the subject. And we can say h is equal to the length of A, which is 3 units, squared, plus the length of C, which is 4 units, squared, all under a square root. Now we can square our values. 3 squared gives us 9, plus 4 squared is 16, all under a square root. Now we can add 9 plus 16, and we get 25 under a square root. The square root of 25 is equal to 5. Now we can see the length of the hypotenuse is 5. So let's clean this up and put our 5 in our diagram over here. Let's do another example. Let's say that our hypotenuse has a length of 13 and side C is 5. Now we need to find the length of side A. To do this, we're going to use this version of the Pythagoras theorem where A is the subject. So now we can say A is equal to the length of the hypotenuse, which is 13, squared, minus the length of side C, which is 5, squared, all under a square root. Now we can square our terms. 13 squared gives us 169, minus 5 squared, which is 25, under a square root. Now we can say 169 minus 25, and we get an answer of 144. Let's put this under a square root. The square root of 144 is equal to 12. This is the length of side A. And we can fill this into our diagram over here. Geometry also taught us that the sum of the internal angles of a triangle is always equal to 180 degrees. That means that if we take this triangle and we say angle A plus angle B plus angle C, we get a total of 180 degrees. And this rule applies to any triangle, regardless of whether it is a right-angled triangle or not. So let's find the value of theta over here. The sum of all the angles in a triangle is 180 degrees. So we can say 180 degrees minus angle B, which is 90 degrees, minus angle A, which is 30 degrees. 180 minus 90 gives us 90 degrees, minus 30 gives us 60 degrees. This is the value of theta. So let's put this into our triangle over here. Now, in many cases, you will not have the values of two sides of the triangle or the sizes of two angles to work with. And in cases like this, we can use trigonometry. The sides and angles in right-handed triangles have common ratios. And as long as we have the size of one angle and the length of one side, we can use trigonometric ratios to find the unknown values. For sine, we say sine theta is equal to the opposite over the hypotenuse. And in maths, we can write this as sine theta equals O over H. For cosine, we can say cosine theta is equal to the adjacent over the hypotenuse. And we say cosine theta is equal to A over H. And for tangent, we can say tan theta is equal to the opposite over the adjacent, which we can write as tan theta is equal to O over A, where theta is the angle. Now, we have just said that the hypotenuse is the side of the triangle directly opposite the 90-degree angle. But what about the opposite and adjacent sides? These sides will depend on where the angle theta lies within the triangle. The opposite side always lies directly opposite to angle theta. So let's draw a line from angle theta to the opposite side of the triangle. This is the opposite side. So over here, we can write opposite. Now, the word adjacent means next to. So the adjacent side lies next to theta, but not the hypotenuse. So in this case, this is our adjacent side. And now let's clean this up and look at our sides if theta is up here. Let's draw a line from theta to the opposite side of the triangle. This side is opposite the angle, so over here we can write opposite. The adjacent side is next to theta, but not the hypotenuse. So in this case, this is our adjacent side. When determining each side, it is always best to start with the hypotenuse because this side is always directly across from the 90-degree angle. Next, we look at where the given angle lies. Remember, the angle can have any name, theta, alpha, beta, or even x. It could also have a defined value. From there, we find the side directly opposite to it. Finally, you can see the third unknown side next to the angle must be the adjacent side. It is very important that you learn these trigonometric ratios for sine, cosine, and tangent. We have found two ways to help you remember these ratios. First, you could use SOHCAHTOA. Sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tan is equal to opposite over adjacent. Or you can use this story. Sally often has cake and has tea ordered also. S for sine, opposite over hypotenuse. Cake, cosine, adjacent over hypotenuse. Or T for tan, opposite over adjacent. You can use either of these ways to remember the sine, cos, and tan ratios, or you can find your own way that works for you. Finally, maybe even more importantly, these sine, cos, and tan ratios only work with right angle triangles. If you do not have a right angle triangle, you cannot use these ratios. Now that we have the basics, let's look at some examples. Use the Pythagoras theorem to find the third side x of the triangle. Then write down the three basic trigonometric ratios for each triangle. Leave your answer in surd form if necessary. And we are given this triangle over here. To find the unknown side, we first need to determine whether or not we have a value for the hypotenuse. So let's draw a line from our 90-degree angle to the opposite side of the triangle. This side is our hypotenuse and it has a length of 10 units. Now that we have our hypotenuse, we can write down the Pythagoras theorem for the other side. In this case, our unknown side is x. So we can say x is equal to the length of the hypotenuse, which is 10, squared, minus the length of the other known side, which is 6, squared, all under a square root. Now we can square our terms. 10 squared is 100, minus 6 squared, which is 36, all under a square root. Now we can simplify. 100 minus 36 is 64. Let's put this under a root as well. The square root of 64 is equal to 8. This is the length of our unknown side. So let's make some space and put 8 into our x value in our triangle. Now we can start by writing down our three trigonometric ratios. Sine is equal to opposite over hypotenuse. Cos theta is equal to adjacent over hypotenuse. And tan is equal to opposite over adjacent. Now to find the actual values of these three ratios, we need to determine each side with respect to theta. We have just said the hypotenuse is directly opposite our 90-degree angle. So in this case, our hypotenuse h is equal to 10, and we can make a note of this up here. Now let's look at our angle theta, and we can draw a line from theta to the opposite side of our triangle. This is our opposite side, which we can see is 6 units. So up here, we can say O is equal to 6. Finally, let's look for our adjacent side. The adjacent side is next to the angle theta, but on the other side of the hypotenuse. So this is our hypotenuse. We can see that this must be our adjacent side. The side is 8 units long. So up here, we can say A is equal to 8. Now we can use these values to find our sine, cos, and tan ratios. Sine theta is equal to the opposite of the hypotenuse. So in this case, we can say sine theta is equal to the opposite, which is 6, over the hypotenuse, which is 10. Let's simplify our fraction, and we get an answer of 3 over 5. Now we can look at cos. Cos theta is equal to the adjacent of the hypotenuse. So we can say cos theta is equal to the adjacent, which is 8, over the hypotenuse, which is 10. Let's simplify, and we get 4 over 5. Finally, let's look at tan theta. Tan theta is equal to the opposite over the adjacent. So in this case, we can say tan theta is equal to the opposite, which is 6, over the adjacent, which is 8. Simplify, and we get an answer of 3 over 4. Let's do another example. And again, we need to solve for x. Before we can do this, let's find the hypotenuse. So we can draw a line from our 90-degree angle to the opposite side. And we see that this is our hypotenuse. It is our unknown side. So we need to use the Pythagoras theorem, where h is the subject. In this case, we are solving for x. So we can say x is equal to one known side, let's say 8, squared, plus the other known side, let's use 5, squared, all under a square root. Now we can square our terms. 8 squared is equal to 64, plus 5 squared, which is equal to 25, under a square root. Now we can say 64 plus 25, and we get an answer of square root 89. Let's make some space, and we can fill the length of the hypotenuse into our triangle over here. Let's also make a note of this up here. Next, we can look at our trigonometric ratios. So let's write down sine theta is equal to opposite over the hypotenuse. Cosine theta is equal to the adjacent over the hypotenuse. And tan theta is equal to the opposite over the adjacent sides. But before we can find the values of these ratios, we still need to find the values of the opposite and adjacent sides in respect to theta. So let's start with theta and draw a line to the opposite side of the triangle. This side is 5 units long. So we can make a note and we say O for the opposite is equal to 5. Now we can find the adjacent side next to theta. We already know that this is the hypotenuse, which means that this side on the other side of theta must be our adjacent side. The side is 8 units long, so up here we can make a note and we say A is equal to 8. Now that we have these values for our sides, we can find our ratios. Sine is equal to the opposite of the hypotenuse. So in this case, we can say sine theta is equal to the opposite, which is 5, over the hypotenuse, which is square root 89. Now we can look at cosine theta. Cosine theta is equal to the adjacent over the hypotenuse. In this case, we can say cosine theta is equal to A, which is 8, over the hypotenuse, which is also root 89. Finally, let's look at tan theta. Tan theta is equal to the opposite over the adjacent sides. So we can say tan theta is equal to the opposite side, which is 5, over the adjacent side, which is 8. And we have now finished this question. In the introduction to our video on reciprocals, we said that to find the reciprocal of a value, we make it into a fraction and we flip it around. So if we have 3 over 4, we flip it and we get 4 over 3. If we have 6 over 7, we can flip it and we get 7 over 6. We now know that sine theta is equal to the opposite over the hypotenuse. Cos theta is equal to the adjacent over the hypotenuse. And tan theta is equal to the opposite over the adjacent side. Now, in our earlier videos, we also looked at reciprocal ratios, and we found that cosec theta is equal to 1 over sine theta. Sec theta is equal to 1 over cos theta. And cot theta is equal to 1 over tan theta. 3 over 4 is the reciprocal of 4 over 3. And 6 over 7 is the reciprocal of 7 over 6. And we have just said that the sine ratio, sine theta, is equal to opposite over hypotenuse. Cosec is the reciprocal ratio. So if sine theta is equal to the opposite of the hypotenuse, then cosec theta is equal to the hypotenuse over the opposite side. Cos theta is equal to the adjacent over the hypotenuse, and sec theta is the reciprocal ratio. So if cos theta is equal to the adjacent over the hypotenuse, then sec theta is equal to the hypotenuse over the adjacent side. Finally, tan theta is equal to the opposite over the adjacent, and cot theta is the reciprocal ratio. So if tan theta is equal to the opposite of the adjacent side, then cot theta is equal to the adjacent over the opposite side. Please remember that these ratios using the adjacent side, the opposite side, and the hypotenuse only work with right angled triangles. Let's look at an example. Use the Pythagoras theorem to find x. Then write down the required ratios, sine theta, sec theta, and tan theta. Let's make some space and start by finding the unknown side of the triangle. Now we have a 90-degree angle, so let's draw a line to the opposite side. Our hypotenuse is the side we need to find. So now we can write down the Pythagoras theorem where h is the subject. Here we are solving for x. So we can say x is equal to one known side, let's say 8, squared, plus the other known side, let's say 15, squared, all under a square root. Now we can square our terms. 8 squared is 64, plus 15 squared, which is 225, all under a square root. Now we can add our values together. 64 plus 225 gives us 289 under a square root. Grab your calculator and we'll find that x is equal to 17. Let's put 17 in the place of x on our triangle, and now we can make some space. 17 is the value of the hypotenuse. So let's make a note of this up here. And now we can find our opposite and adjacent sides in terms of theta. Let's draw a line from theta to the opposite side of the triangle. Our opposite side has a length of 8 units. So up here, we can say O is equal to 8. Now let's find our adjacent side. Our adjacent side is next to theta, but not the hypotenuse. So in this case, this is our adjacent side. The side is 15 units long. So up here, we can say A is equal to 15. Now we have a value for the hypotenuse, the opposite and adjacent sides. And then now we can write down the 3 ratios we need to find. The phrase SOHCAHTOA helps us to remember that sine theta is equal to the opposite over the hypotenuse. Cos theta is equal to the adjacent over the hypotenuse, and tan theta is equal to the opposite over the adjacent side. We now also know that the reciprocal ratio cosec theta is equal to the hypotenuse over the opposite side. Sec theta is equal to the hypotenuse over the adjacent side, and cot theta is equal to the adjacent over the opposite side. And now we've got enough information to find our given ratios. Sine theta is equal to the opposite of the hypotenuse. So in this case, we can say sine theta is equal to the opposite, which is 8, over the hypotenuse, which is 17. Sec theta is equal to the hypotenuse over the adjacent side. So now we can say sec theta is equal to the hypotenuse, which in this case is 17, over the adjacent side, which is 15. Finally, we know that tan theta is equal to the opposite side over the adjacent side. So in this case, we say tan theta is equal to the opposite side, which is 8, over the adjacent side, which is 15. Let's do one last example. Determine the value of x, tan theta, and cosec theta. Let's start by solving for x. And to do this, we first have to find the hypotenuse. Let's draw a line from our 90-degree angle, and we see that this is our hypotenuse. Now we can use Pythagoras to find the length of the unknown side. Our unknown side is x, so we can say x is equal to the value of the hypotenuse, 5 squared, minus the value of the other known side, 4 squared, all under a square root. And now we can square our terms. 5 squared is 25, minus 4 squared, which is 16, under a square root. 25 minus 16 gives us 9 under a square root, and we get an answer of 3. Let's make some space and put 3 in the place of x in our triangle over here. Now we have just seen that our hypotenuse is 5 units. So let's make a note of this up here. And now we can find our opposite and adjacent sides. Let's draw a line from theta to the opposite side of the triangle. This is our opposite side, which has a length of 3 units. So up here, we can say O is equal to 3. The adjacent side is next to theta. We know that this is our hypotenuse, which means that this is our adjacent side. And let's make a note of this up here. And we can say A is equal to 4. Now we can use SOHCAHTOA to write down our ratios for sine, cos, and tan. Let's also make a note of our reciprocal ratios. Now we have the values for the hypotenuse, the opposite, and the adjacent sides, as well as our trigonometric ratios. So now we can find the value of tan theta. Tan theta is equal to opposite over the adjacent side. So in this case, we can say tan theta is equal to the opposite side, which is 3, over the adjacent side, which is 4. Now let's look at cosec theta. Cosec theta is equal to the hypotenuse over the opposite side. In this case, h is equal to 5. So we say cosec theta is equal to 5 over the opposite side, which is 3. And we have now completed this question.